if you're not already there, go ahead and get there. We're going to look at this section in our notes. We'll just do this page, and this will be just fine. Just a reminder for you guys that do I see you Tuesday? That's right. I see you Wednesday. So when I see you Wednesday, I believe that there is an intro video for the next little bit of 2.1 that would be due Wednesday before class. So please do make sure that you complete that before then. You've got quite a bit of time. So whenever you find time to do that, the next 4 or 5 days, or 4 days, whatever it is. All right, so...
I think it's in Edpuzzle is due Tuesday. I'm not sure. It's in Edpuzzle, I believe it says it's...
So yeah, Edpuzzle, I'll check that. I don't really go by the Edpuzzle due date. It doesn't really affect much. I just check it like right before class and take a screenshot. So yeah.
So it says midnight, watch before class.
Always watch before class because it's an intro video. Yeah. Okay, so this will be the one time we do this year, unless you want to do it other times. This question right here says, use the definition of the derivative to find g prime if g equals that. So we're going to find out pretty quick that there's this thing called the power rule that would make this like a 2-second operation. But I want to show you where this comes from and just remind you what you did a lot of in pre-calculus. And so do this with me. But know that we'll do some different stuff with this. I think there's some value in doing this. But please know that we'll do other kind of things with this as well. You'll see that as we move forward. So the definition of the derivative is right here. So I would say g prime of x is equal to the limit as h approaches 0 of g of x plus h minus g of x, all divided by h. So that's that familiar format you guys saw in pre-calc. You guys said you saw it a ton and did a lot of exercises with this. So hopefully this will feel pretty familiar. So g of x plus h, that's going to be the first piece we need to evaluate. Can everybody explain what g of x plus h is kind of telling us to do? It's telling us to do something. What is it? Nothing. You guys just tired? No idea?
Wherever there's an x in g of x, you put an x plus h.
That's it. There we go. Thanks, Max. So wherever you see an x in g of x, like he just said, you put an x plus h, sorry. So I'm going to write limit as h approaches 0, and I'm going to put something squared plus 2, and that something is x plus h. So that goes right here. So there's g of x plus h. I'm supposed to subtract from that g of x. So g of x is just that x squared plus 2. You probably remember that it's a key idea is to put parentheses around something like that so that you end up subtracting the whole thing, not just the first term. And still all over h. Please notice one of the key features of what I'm doing here is my limit has not disappeared. That's a real tempting thing to do in a scenario like this. Hasn't disappeared, still sitting there. And so maybe we try to evaluate the limit right now. If you do, what happens? 0 where? Denominator. And isn't by its very nature the derivative always going to do that? Like that's what makes it the derivative. So we're going to have to do some work to see what we can do about that. Does anybody see any like algebraic kind of steps that we could take to maybe get us on the way? Yeah, go ahead and square the binomial. Yeah, totally. So if you do that, you get limit as h approaches 0. And that ends up being x squared plus 2xh plus h squared, if you FOIL it out, plus 2. And then why don't we just distribute the minus sign at the same time? So minus x squared minus 2 all over h. If you try to evaluate the limit again, don't we get the exact same problem? Something over 0. So we can't do that either. But there's a bunch of stuff in the numerator that will nicely add right on out of there. So the x squareds will add out. The plus 2 and the minus 2 will add out. And so then after I do that, I am left with the limit as h approaches 0 of 2xh plus h squared all over h. And once again, we mentally think about what would happen if I tried to evaluate this limit, and what would happen? We're not done yet, right? So what's kind of the final step that we would need to take here to get this to work? Factor out an h. That's right. So if I factor out an h, I end up with h parentheses 2x plus h all over h. And this, of course, the key step, because now you can just divide out or cancel out those h's, this one here and this one here, leaving us with the limit as h goes towards 0 of 2x plus h, and that would equal 2x. So, as a general rule, we will never go through this process from a respecting our time perspective. We can do this much faster with other rules, namely for this one, the power rule. But again, I wanted you just to see it, be reminded of what you did in the past, so we can kind of connect it as we move forward. Is that okay? All right. So, do you guys remember the very first day of school, like roughly 2 weeks ago? Very first day of school. Remember I had you guys use the iPad and you made something? Or a slope field? Wasn't it a circle? It was a circle, yeah. So when I first started talking about that, I mentioned to you guys that, in pre-calculus and algebra 2, you guys got fairly comfortable with graphing things where y was depending on x, where like the x-axis stood for the x-coordinate and the y-axis stood for the y-coordinate. You've done that forever, right? For a long, long time in math classes. And I mentioned that here in this class, we're going to do some different stuff. And the first thing that was different was that slope field where we graphed slopes based on x's and y's, right? And so, bless you, this, my friends, will be kind of another effort in that direction. What we're going to do here is, there's 3 different graphs right there, so this is 3 different questions. What we're going to do is we are going to look at the graphs of f, as you see there below, and we are going to sketch the graph of f prime right on top of it, okay? So let's keep in mind a couple of things here. What does f prime describe in regard to the graph of f? Describes its slope. Yes, describes its slope. So the first one is actually, we're done at, when are we done, 55? 55, okay, yeah, that's what I thought. I just want to make sure. First one's going to be really straightforward, because what does the first one appear to be as far as the graph goes? A line, right? It appears to be totally just like a regular old straight line. What is a unique feature about the slope of a line? No matter which x value you're at, the slope is the same. That's what makes it a straight line. The slope is the same at every single point. So if I were to look at this line here and say, all right, when x is 2, the slope is what? 2. Doesn't it look like the whole line has a slope of 2? So when x is 2, the slope is 2. When x is 3, the slope is 2. When x is -1, the slope is 2. The slope is 2 no matter where you are on the line, right? So here's how you would graph the f prime for this graph. I'll put this in this blue color. So we're just going to basically plot points, except the x-coordinate is going to be the x-coordinate, and the y-coordinate is going to be f prime. Make sense? So check this out. When x is 2, f prime is 2. Make sense? So I'm double using the y-axis, right? So the y-axis for the black line stands for y, but for my graph, it's going to stand for f prime. Okay, I'm kind of double using it. All right, when x is 3, f prime is 2. When x is -1, f prime is 2. And really, it doesn't matter what the x-coordinate is. Isn't f prime always going to be 2? So I could just put in a series of points here. What pattern do I have developing? Horizontal line, right? So if I were to try to connect all those, I would see that the graph of f prime is simply going to be a horizontal line, because the original line, right, has a constant slope, which would mean that f prime would be a horizontal line. It's always going to have the exact same value. So that's definitely the easiest example, right? So what I'm going to do here, this will be our last one here today. I want to look at this more curvy graph. Have you ever, these are kind of old. You guys remember those magic eye paintings? Remember the magic eye paintings where you'd stare at it and like be unfocused and then you'd see something? Yes? I struggled with those for a while. Eventually I got to a place where I could see them. I feel like this is the same way. Like there's almost inevitably going to be some folks that are like, they just kind of struggle with this, and I totally get it. But once it like clicks for you, I think it'll click for you. And I want to give you a system to kind of help you with that. So when you get to these curvy graphs, here's the system I use. First question I ask is, where does the tangent line appear to be horizontal? So let's ask that question first. So on this graph, I'm looking at this middle one right here. On that graph, how many places do you see where it appears the tangent line would be horizontal, just like totally flat? What do you see, Sam? I see 3 as well. So don't write this in. I just want to illustrate this. I see a horizontal tangent line at every single turning point. Do you see them? And the slope of a horizontal line is 0. So wherever F has a turning point, a high point or a low point, F prime should be 0 there, okay, for these nice, smooth, curvy graphs. So here's what I'm going to do. Wherever F prime is 0, I'm going to put those points here, here, and there. Does that make sense? Do you see how they vertically line up? So when x is 2, F prime is 0. Same is true for x equals -1 and x equals -4. That make sense? Okay. Again, for these nice curvy graphs with no sharp points, we'll talk about those later. I'm going to also ask myself, where is the tangent line, where's the slope of the tangent line positive, and where's the slope of the tangent line negative? And having those zeros on there is immensely helpful. So I am going to look at this in little segments. I'm going to look at this little part right here. Would you say the slope of the tangent line on that brown highlighted part, is the slope of the tangent line positive or negative? Because the graph of f is increasing, right? Okay, so a positive number would actually appear above the x-axis on our f prime graph. So I'm just going to sketch that in right there. Now I have it going towards the 0 because I pre-graphed the 0, which tells me I need to go there, right? And so since graph of f is increasing, my slope, my f prime, will be positive. It's going to be above the x-axis. Now take a look at this little red segment. Wouldn't you guys agree that from here to about there, wouldn't you say the graph of f is decreasing? And if f is decreasing, then we probably would describe f prime as being negative, right? Decreasing graph has a negative slope. And since f prime describes the slope of f, we say that f prime is negative. So that means we've got to be down here below the x-axis. We've got to be down here somewhere. But I know that I've got to head towards that 0. And so I'm thinking that this part of the graph should look like this. Then, we just hit our time. I'll finish up in just a second. Look at this little blue stretch. Would you say that the slope of the tangent line on the blue stretch is positive or negative? Positive, right? Because f is going uphill. It's increasing. And so positive values will appear above the x-axis. But I know that I've got to hit that 0 again. So I drop back down. Then, finally, on this green stretch right here, just this last little bit, do you see how f starts to decrease? Which would mean the slope of f is negative, which means f prime is negative. And so I would graph that little stretch below the x-axis. And so that blue graph there would be the graph of f prime. And if you follow that system I just described there, I think it's going to go okay. We'll practice this some more when I see you guys next week on Tuesday. Hope you have a great weekend.
Thank you, Mr. Anderson.
Thank you. Do you feel okay?